myself Pooja Sharma. I'm assistant professor in computer science and engineering department in Ajay Kumar Girl Engineering College. In today's lecture, we will discuss about the symbol table, unit 4 topic in compiler design. So, symbol table is an important data structure basically created and maintained by the compiler in order to keep track of semantics of variable. That is, it store information about the scope and binding information about names, information about instance of variable entities such as variable and functions name, class and objects and etc. Basically, symbol table is used by the all phases of compiler in different manner. It is a built-in lexical syntax analysis phase. The information is collected by the analysis phase of the compiler and is used by the synthesis phase of the compiler to generate code. Basically, machine code. It is used by the compiler to achieve compile time efficiency. So, uses of symbol table by various phase in lexical phase. In first of all, in lexical phase, the symbol table is used to create a new tables in the new entries in the table. Suppose like entries about tokens. As we know that in lexical phase we create a tokens. And now second is syntax analysis phase. In syntax analysis phase, symbol table adds information. In symbol table, we have to add information regarding attributes, type, scope, dimension, line of references, and uses, etc. Semantic analysis phase uses available information in the table to check for semantics. That is, to verify that expression and assignments are semantically correct or not, and updated accordingly. Next phase is intermediate code phase. Intermediate code phase refers symbol table for knowing how much and what type of runtime is allocated, and table helps in adding temporary variables information. Next phase is code generation phase. Code optimization phase. In code optimization phase, we use symbol table for information present for machine dependent optimization. Last phase is target code generation phase. Generate code by using address information of identifier present in the symbol table. Now, the information in symbol table. Each entry in the symbol table is associated with the attribute that support the compiler in different ways. We store information in symbol table, that is name of the identifier may be stored directly or as a pointer character string in an associated string table. Names can be arbitrarily long. Second is type of the identifier, where that is variable or label, procedure name, etc. For a variable, it's type, basic type, derived type, or so on. Next is location, where variable is stored. Offset within the program, where the identifier is defined. Scope, region of the program where the current definition is valid. Other attributes also we have stored in symbol table, that is array limits, fields of record, parameters, written value, and so on. Now, the information used by the compiler for symbol table. Data types and names, declaring procedure, offset and storage. If structure or record, then a pointer to structure table for parameter, whether a parameter passing by value or by reference. Number and type of argument passed to function, and then and last is base address. So there is 4 type of implementation we have done symbol table implementation. First is list, linked list, binary search tree, and hash table. If a compiler is to handle a small amount of data, then the symbol table can be implemented as an unordered list, which is easy to code, but it is only suitable for small table only. Now, first is list. In list, an array is used to store names and associated information. A pointer available is maintained at the end of the storage record, and new names are added in the order as they arrive. To store for a name, we start from the beginning of the list till available pointer, and if not found, we get an error use of the undeclared name. While inserting a new name, we must ensure that it is not already present, otherwise an error occurs, that is multiple defined name. Insert is fast, is big O one, but lookup is slow for last table, that is big O n. On average, the advantages is that is to take a minimum amount of space. Next implementation of symbol table is done by linked list. This implementation is using a linked list. A link field is added to each record. Searching of name is done in order pointed by the link of the link field. A pointer first is maintained to point the first record of the symbol table. Insertion is fast, that is big O1, but lookup is also slow for last table. Next is hash table. Hash table in hashing scheme, as we know, in a hashing scheme, two tables are maintained. Basically, a hash table and a symbol table, and are the most commonly used method to implement symbol table. A hash table is an array with an index range 0 to table size -1. Suppose table size is 10, then maximum size of hash table is 9. These entries are pointers pointed to the name of the symbol table. To search for a name, we use a hash function that will result in an integer between 0 to table size -1. Insertion and lookup can be made very easily. That is, order of complexity is order of 1. The advantages is quick to search is possible, and the disadvantage is the hashing is complicated to implement. Next implementation of symbol table is binary search tree. Another approach to implementing a symbol table is to binary search tree. That is, we add two links fields, that is left child or right child. All names are created as child of the root node that always follow the property of the binary search tree. Insertion and lookup are order of big O of log to n on average. So these operation we have to perform on symbol table. First operation is allocate, free, lookup, insert, set attribute, and get attribute. These are the main operation we are used and performed on symbol table. First is allocate. Basically, allocate operation function. It means to allocate a new empty symbol table. Free operation. Free operation means to remove all entries or free storage of symbol table. Lookup. This is the most important or most used operation in symbol table. To search for a name and return pointer to its entry. To insert a name in a symbol table and return a pointer to its entry. Set attribute function. Set attribute means to associate an attribute with a given entry. Get attribute to get an attribute associated with an given entry. Now, more important operations are there are two mainly most important operation is lookup operation and insert operation. So first is insert operation. In insert operation, basically is more frequently used in the analysis phase when the tokens are identified and names are stored in the table. The insert operation is used to insert the information in the symbol table like the unique name occurring in the source code. In the source code, the attribute for a symbol is the information associated with that symbol. The information contains the state, value, type, and scope about the symbol. The insert function takes the symbol and its value in the form of argument. So basically, this is the syntax of insert for operation. Insert x comma int. We have to insert x and its type is int. Now next operation is lookup. In the symbol table, lookup operation is used to search a name. Basically, it is used to determine the existence of the symbol in the table, the declaration of the symbol before it is used, check whether the name is used in the scope, initialization of the symbol, checking whether the name is declared multiple times. The basic format of lookup function is this: lookup and then symbol. So this is an example. Bar is an external function and foo is an public function. So how we can store information about that function in symbol table? Suppose in symbol table, bar is a function, that is an external function. So we have store bar and its type is function with type is double and is scope is extern. So, okay, next is the x. X is a variable and its type is double and it is an function parameter. Okay, function parameter. Next is foo. Foo is also a function, public function, and its return type is double, and it is an scope of foo function is public. This is a symbol table bar. This is a function, type function, and double, and scope is extern. X is in type of double and it is a function parameter. Foo is also a function with return type double and scope is global. Count is an integer type and it is also a function parameter. Next is sum. Sum is an double and it is block local. Scope is block local. I is an integer type and it is declared in for loop statement. Okay. Now, representing scope information. In the source program, every name possesses a region of validity called the scope of that name. The rules in the block structure language are as follows. If a name declared within a block B, then it will be a valid only within B. Suppose in this example we have declared sum in this function, then some variable is valid only in this function. Okay, we cannot use some variable outside this function. Now, if B1 block is nested within B2, then the name that is valid for block B2 is also valid for B1, unless the names identifier is redefined in B1. These scopes rules needs a more complicated organization of symbol table than a list of association between names and attributes. Tables are organized into stack and each table contains the list of names and their associated attributes. Whenever a new block is entered into a new table is entered onto the stack, the new table holds the name that is declared as local to this block. When the declaration is compiled, then the table is searched for a name. If the name is not found in the table, then the new name is inserted. When the name's reference is translated, then each table is searched starting from the each table on the stack. Again, this is an example. Int x, void f is a function, and float x and y also declare in function f. And then I, J, U, V, these also are the variables that are declared in function f. Now next is G. G is another function. So this is an symbol table organization. First is a global symbol table. In global symbol table, X is globally defined. Okay, X is globally defined and it is a variable and its type is int. F is a function. There are two functions, F and G. F is a function and its return type is void, and G is also a function, its return type is int. Next is F function table. In F function table, M is a parameter type of int, X is also a variable that is float, Y is also a variable of float. X, Y. Okay, now after that, we can see that I and J, U and V. Okay, there are four variables also. I, J, U and V. I, J, U and V are variables and they are of integer types. Okay, declared inside the F function. Now in G function, in G function, n is a variable. N is a variable and T also a variable. There are two variables, n and T. Then n is a parameter passed in the function. Then integer type and its type is integer. F is a variable that are used in inside the G function and its type is boolean. Okay. Okay, this is the symbol table organization. Now next is runtime storage administration. In runtime storage administration, high level, we have written a program in high level language. After that, that program is compiled by the compiler, and then target code, that is assembly code, is generated by the compiler, and it will store in the operating system. So the utility of memory with the help of OS is called a runtime storage administration. So format of runtime storage administration, there are four type of memory we have used: heap, stack, static, and code area. Heap and stack are dynamic memory allocation. Static, that is global data, or code area is in compile time memory allocation. Static global data is of fixed size and hold constants and global values. Code area is is also an fixed size and holds target code. And the mechanism by which storage memory can be allocated to variable during the runtime is called an dynamic memory allocation. There are three types of memory allocation: static storage allocation, stack storage allocation, and heap storage allocation. In static storage allocation, names are found to store location. If memory is created at compile time, then the memory will be created in static area. And static allocation supports the dynamic data structure. That means memory is created only at compile time and deallocated after program completion. The drawback with static allocation is that the size and position of data objects should be known as compile time. Another drawback is restriction of the recursion procedure. Next allocation of memory allocation is stack by stack. In stack storage allocation, storage is organized as a stack. An activation record is pushed into the stack. When activation begins, it is popped when the activation ends. Activation record contains the locals so that they are bound to fresh storage. In each activation record, the value of locals is deleted when the activation ends. It works on the basis of last in first out LIFO, and this allocation support the recursion process. So we have used activation record. And what do you mean by activation record? First of all, we discuss about activation record. Activation record basically a data structure that is created when a procedure is invoked, and it contains the following information about the function: Control stack is a runtime stack which is used to keep track of the live procedure activation, that is used to find out the procedure whose execution have not compiled. When it is called activation begin, then the procedure name will push on to the stack, and when it return activation and then it is popped. Activation record basically is used to manage the information needed by a single execution of a procedure. In execution record is pushed into the stack when a procedure is called, and it is popped when the control return to the caller function. So in activation record, there is a return value, actual parameter, control link, access link, save machine status, and local data and temporary. Okay, functions that are used in activation record. First is we see that first is return value. In return value, it is stored by calling procedure to return a value to calling procedure. Actual parameter, it is used by calling procedure to supply parameters to the called procedure. Control link, basically it points to activation record of the caller. Access link, it is used to refer to non-local data held in other activation record. Save machine status, it holds the information about the status of machine before the procedure is called. Local data, it holds the data that is local to the execution of the procedure. Temporaries, it stores the value that arise in the evaluation of an expression. Now, last is heap storage allocation. Heap storage is the most flexible allocation scheme. Allocation and deallocation of memory can be done at any time and at any place depending upon the user requirement. Heap allocation is used to allocate memory to the variable dynamically, and when the variables are not used, are no more used, then claim it back. Heap storage allocation support the recursion process. This is an example of heap allocation. Factorial, we have to find a factorial of any given number, that is n. So first of all, we have to find, suppose we have to find a factorial of 5, then 5, and 6, then first function is called, then for n is less than 1, yes, and n is not less than 1, then we have to return and multiply fact n minus 1. Okay. After that, this recursion function will done when n is equals to 1. Okay, after that we get the result, that is 720. Okay, so this is all about the symbol table and runtime storage allocation. So in the next lecture, we will discuss about the code generation phase, that is the last phase of the compiler design. So this is, thank you so much.